Good afternoon, everyone, and welcome to North East Water's Community Webinar Series. Today's webinar is all about our Wodonga Wastewater Treatment Plant upgrade. My name is Jo Murdoch and I'm the Managing Director of North East Water. I'm delighted to have you with us today. North East Water acknowledges the traditional owners of the lands and waters on which we operate and are meeting today. We pay our respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people here today. Now, before we get started, I would like to go over a few housekeeping items so that we have a smooth session. Please note that all audience members have had their cameras and microphones switched off for this webinar. And this webinar is being recorded and will be available via our website after the session. We encourage you to ask questions. You can submit your questions at any time using the Q&A function, and we'll address as many of those questions as possible during the Q&A segment following the presentation. And those that we don't get to, we'll add to our website. Now, before we dive into our main topic, I would like to give you a brief overview of North East Water and what we do. Now, essentially, we plan for and provide critical water and sewage services to 39 towns across a 20,000 square kilometre region. We serve over 120,000 people, ensuring they have access to high quality, clean and safe water. We operate 21 water treatment plants and 22 wastewater treatment plants. And our extensive pipe network includes 1,300 kilometres of sewer mains and 1,800 kilometres of water mains. And with assets valued at $1.6 billion, we are committed to investing in and maintaining our infrastructure to meet current and future needs. You may also not know that North East Water has one of the lowest water bills in Victoria and the nation. And we are proud to employ 208 local employees who provide exceptional service and support to our community. North East Water recently launched its new corporate strategy following 12 months of engagement. Strategy 2040 sets out our vision for the future, where North East Water proactively contributes to a healthy environment, thriving community and prosperous region. It makes very clear that our purpose is to deliver safe, sustainable water and wastewater solutions for our communities. And there are many elements to Strategy 2040, but three that are particularly relevant today. And the first is that North East Water is proactively planning for the future, and that's a future to cater for residential and industrial growth and prosperity. Today's presentation demonstrates this for Wodonga, our region's largest city. Secondly, we want to do everything we can to not only reduce energy and waste costs, but to go further and transform waste into a valuable resource. And thirdly, we want to proactively, and we are proactively partnering with government, industry, councils and other key stakeholders to maximise the synergies between our wastewater treatment plant and industry. In other words, looking for circular economy opportunities that improve environmental outcomes, reduce costs and support healthy communities and a prosperous region. Once again, thank you for joining us today. I'll now introduce our presenters, Kevin Freeman, North East Water's Strategic Investments Lead, and then following that, John Day, General Manager of Environment, Systems and Operations.
Thanks, Jo. Hello, everybody. I'm Kevin Freeman, and I'm the project manager for this project, which we have titled our Capacity and Emissions Reduction Project. So what you could probably get out of that very quickly is the need for this project is really underpinned by a requirement to provide capacity for future growth in Wodonga. It was recognised some years ago that the existing plant is nearing capacity and we needed to commence to do something to provide for the upcoming growth. So from an economic point of view, this project is really about supporting the regional growth around the Wodonga and surrounding townships through to around about 2040 to 2045. An opportunity when we're planning for this project really arose about, well, how could we do it in a way that was going to support the environment and other objectives that we had on our cards at the time. And certainly a large objective driven through the state government is around reducing our environmental footprint. And this project provided some really good opportunities as the existing plant in Wodonga treats a high amount of trade waste load from some of our industrial customers. And because that load is, those loads or flows are quite low, represents about 10% of our flow, but around about half of our load, it really opened up the opportunity. So, well, do we just build more of what we're currently doing, or is there a smarter way of dealing with that? And all the analysis work that underpinned the project identified that introducing anaerobic treatment was a smart way to go forward. And I'll discuss that a little bit later. The other thing that obviously the plant's trying to, or the project's trying to do from an objectives point of view is make social benefits more broadly across our customer base into the future. And this project has been designed to enable, what I said before, significant growth within Wodonga and surrounds. Around about 40-odd thousand new people it will service, plus also service the ongoing and growing requirements of our industrial trade waste customers. And finally, to be consistent with North East Water's commitment to our Aboriginal parties and peoples, cultural heritage was forefront of our planning, and we've worked very closely with our local Indigenous parties to get the project up and running. So just in respect to just what the project really is trying to do, you can see on this slide here, it's a little bit of it's a picture of two of our, I guess, the workhorse of the treatment plant. There's two biodigesters there in the middle, sort of big concrete structures. And what a treatment plant of this type does is it takes wastewater and it uses aerobic processes essentially to break that wastewater down. And what it's trying to do is get rid of organic matter and nutrients. And it takes a lot of energy, particularly to get rid of the organic matter. As I said, this plant takes a lot of trade waste load, so it is very high in organic loads. So the ability to take those loads out of the existing two bioreactors and do something different with that really frees up capacity within those existing facilities to cater for ongoing residential growth within Wodonga. So really what we're doing is diverting the high strength trade waste and putting it through a side stream anaerobic treatment process. So why is a anaerobic treatment process suitable for this project? Fundamentally, low flows, high loads really lend themselves to anaerobic treatment processes. And then when I say anaerobic, what I mean is we treat that water in the absence of oxygen, which means we no longer need to spend significant amounts of, or use significant amounts of energy to put oxygen into the processes, thus reducing the overall environment or overall electrical requirement to run the treatment plant. The really great thing about anaerobic treatment processes too is they do produce a byproduct called biogas, which is fundamentally methane, around about 70% methane. And that biogas can be reused or used to run through an electrical generator to produce renewable electricity, which we can then use to operate and run the plant behind the meter when that requirement is there. And if there's excess electricity, we can then send that off-site back to the electricity grid, and that helps us offset our electrical use elsewhere within the system. That's fundamentally it on a nutshell. I think we might go to the next slide, please, and I'll just sort of talk a bit through some of the different components of the facility. So I've got a few slides here of some rendered images of the site and of the works. So really, you can see in the foreground, to the right of that picture, is those two existing bioreactors I was talking about earlier. So in essence, we are diverting from those two bioreactors the trade waste and heading across to the land that's part of the site to the west of the existing treatment plant, to top right where you can see some infrastructure up in there to run the anaerobic treatment processes up in there. Ultimately, after it goes through the anaerobic treatment processes, it's then returned back to this existing plant. We do have an upgrade in the existing plant to provide some ability to help remove nutrients One of the good things about anaerobic treatment, very good at managing or dealing with organic load and breaking it down, but it doesn't do anything to nutrients. As a wastewater treatment plant that discharges back to inland waters, we have very strict requirements on the quality of the wastewater that leaves the site, and nutrients, particularly nitrogen and phosphorus, need to be removed. So this facility still helps us to reduce those nutrients to avoid below our discharge licence requirements with the EPA. Next slide, please. So this is just a rendered image looking back from the other direction. So essentially what we have here is the diverted wastewater will come into a new inlet works that will have odour control facilities on it to ensure that we manage potential odours from the site. In essence, this will improve the overall odour capacity or odour management capacity of the facility for a number of reasons. Firstly, the trade waste treatment will come through a more fit for purpose odour treatment system, which will consist of biological treatment processes and activated carbon to remove those odours. And secondly, the existing plant will move from a state where it's getting close to being at capacity or at times potentially overloaded, and thus removing the potential odour capacity of that plant if it goes into an overloaded state. So really will improve odours quite significantly from the site. Following that, the wastewater is then split and goes through a couple of different processes, primarily due to the type of trade waste that we receive. Trade waste is from an abattoir and a pet food manufacturer, which means it potentially has high fats, oils, and greases attached to them. So we split those fats, oils, and greases out, and we provide some preliminary pre-treatment of those through higher temperature digesters to really facilitate and supercharge the breakdown of those fats, oils, and greases, so it doesn't cause downstream issues. It's interesting that the heating of those digesters ultimately is comes from when we burn the biogas back through electrical generators. It produces heat, and we capture that heat and put it back into the process to have a closed loop in that space there. Ultimately, then all the wastewater then flows through to covered anaerobic lagoons. They provide robustness to be able to manage a highly variable waste stream over a period of time. So if there's any issues or with what comes in, they really dampen that out and ensure that we don't have any possible exceedance coming to the downstream infrastructure when we go to run and meet our EPA licence requirements. They also run a secondary purpose, and that is to store the biogas that's produced. The biogas is stored underneath the covers, and then it's withdrawn from those covers on a daily basis to be put back through the generators or flared if required. Following all of that, the wastewater stream is then sent back across the existing plant, as I discussed before, goes through some pre-treatment facilities that will be built to remove the nutrients before being mixed back with the overall loads to be discharged from site. So that's a really quick overview. There's a fair bit more in it, but that's really the main processes and the things that have been built in that point there. It is a large construction project. Essentially, we're doubling the capacity of the plant. So we've entered into a 2-year design and construct contract with Icon Water, and then in partnership with a few other companies, one being CCB and Venco, who've done a number of works with us, and Loricurran Water as well. They've got a lot of history with water and wastewater infrastructure development. As an entity group, they have delivered a number of wastewater treatment plants together. Recently, Druin Wastewater Treatment Plant was built by this contracting entity, as well as the Warrnambool Wastewater Treatment Plant is currently under construction as well. So they do have a lot of experience in this space. respect to the, I guess, the flow-on effect from works of this type, we expect over the course of the project, at least over 50 local trades and people will be utilised through the works. There's a number of subcontractors, key subcontractors already engaged under the project who are locally based, which is fantastic to see. And if you want to try and put it back to a full-time equivalence point of view, it's around about 16 full-time jobs over the 2-year period that this project will be supporting going forward. So once again, a great outcome for our local communities. Yeah, so I'll leave it there. I'll pass across to John now, who will talk a little bit about some of the operational benefits.
Yeah, thanks, Kevin. And look, what this really gives the operators at the West Wodonga site is better operational control by taking off, as Kevin said, some of that capacity being relieved by reducing the amount of trade waste that was traditionally going into this plant mixed with the municipal waste. Now gives us some capacity by separating those out. That then means that they've got a lot more capacity to close pieces of the equipment down, to maintain it, to repair it. But it also gives us a lot of opportunity around trials. So currently, because you're at full capacity, running different trials with different types of aerators, different equipment becomes very difficult because you don't have that capacity. So by having this capacity, we can now start to run some more trials and more efficient ways of running this plant. It also reduces the cost on the plant. As you heard from Kevin, the energy produced at that site will be from biogas and also from solar. So effectively that plant could be turned off from the grid and run sustainably with its own energy through the day, through solar, and through the biogas through night. So that really starts to make a very efficient and cost-effective way of treating wastewater. The other part to that is sludge digestion. So while it doesn't sound like a very sexy topic to talk about sludge digestion, what that really means for us is that we're actually able to start to reduce our odour emissions. So whenever you're treating wastewater, the first thing that's going to be reduced is emissions and carbon emissions through hydrogen sulfide or nitrous oxide. The enhancing of that sludge digestion is going to significantly reduce those. Next slide, please, Luke. But then the really exciting part about that is, as I said, around this connection between solar generation during the day, biogas generation at night, but also with the collaboration that we've formed with the Australian Gas Infrastructure Group, who are building their hydrogen facility at the top corner of that photo. Now, what does hydrogen mean for us? Well, the reason why we've worked with AGIG to build their plant on our site is they need two inputs, one being water, and that can be through the supply of recycled water, which is what we make at this plant to produce hydrogen, and their waste product is oxygen. Now, if we use that pure oxygen back through the plant as part of our process, because the bugs inside the plant require oxygen to survive, just like us, that pure oxygen can also be another way of reducing our carbon emissions. It is evidence so far around the chance of pure oxygen being able to reduce nitrous oxide, which is one of the more heavier gases that's released to the atmosphere from a operation of a wastewater treatment plant. So with both of those plants working together, it is really a circular economy outcome that you can see that energy is reduced within the plant. The hydrogen is then having its waste products coming back through our business to then actually reduce even our waste. And at this whole site, there will be nothing that will be considered as a waste, but as we've called it, a resource recovery hub. That also opens up the opportunity of an education hub at this site. So we're currently working with Victorian Uni on some work around the recycled water. You can see that a lot of universities and education streams are very interested in the STEM opportunities of learning around renewable energy, hydrogen energy, circular economy outcomes, and nature positive outcomes. So ultimately, this whole site will certainly be a showcase, not only for Victoria, but for nationally, around how you can take what was dealing with waste to now a resource recovery hub that everything is valued. I might hand back to Joe.
Thanks, John, and thanks, Kevin, for giving us a really great overview of the project. And I did want to call out, actually, we do have a couple of our large industrial custom and trade waste customers on this webinar today, and we're working very closely with Mars Pet Care, for example, and Wodonga Rendering and the Australian Gas Infrastructure Group. And so thank you for your involvement in this. We have only one question that has been posted, so I'm going to read that out. But in the meantime, others, you might have another question if you've been sitting there listening to this presentation. And this is from Kerry. And Kerry has asked, has this process been used successfully in other wastewater treatment facilities? And I'm going to throw that to you, John.
Yeah, thanks, Joe. I was nearly going to throw it to Kevin, but yeah, as part of the design work that Kevin did, and certainly he took some operators up to Goulburn, I think it was, Kevin, and some other sites. And a very similar plant to this is currently or has been built at Colac by Barwon Water. So there are quite a few of these plants and these designs, and it's becoming more and more the standard, instead of just duplicating what we currently had there, to build these systems that can then utilise the gas, because gas, as you can imagine, is a product that's been well sought after, and biomethane very much so, not just for energy generation, but even to run vehicles, to generate heat, all sorts of outcomes from biomethane.
Right, fantastic. Thanks, John. I don't know, Kevin, did you have anything else you wanted to add to that?
All I'd add is anaerobic digestion is not a new thing. It's been around for over 100 years, used in various projects throughout the world. I guess recently in Australia, it's probably the last 10 years, it started to get a little bit more back in fashion, and it's plants like Melton, Colac and Shepparton use similar sorts of processes. So we certainly being able to learn and lean on what's been done elsewhere, and pleasingly our contractors have been involved in the delivery of some of those projects. So we've got people that know what they're doing.
Yeah. Fantastic, Kev. I had a question that somebody asked me before the webinar, actually, and that was about how important is it that major industry is located near wastewater treatment plants, or vice versa. For example, hydrogen and wastewater treatment plants seem to go very well together. John, do you want to just explain the significance of this, of that statement, I suppose, and why it's so important?
And look, Joe, this site's really unique in that if you look at wastewater facilities across Australia, very rarely has a business actually separated the industrial lines from the municipal lines, so wastewater coming from town. That's then given us that opportunity to separate out and be able to build this covered anaerobic lagoons system. We wouldn't have been able to do that otherwise. So then we can utilise industry's waste, if you like, in that circular economy outcome. But also co-locating hydrogen, as I've touched on before, the benefits of reusing and turning what was waste, that oxygen opportunity to put oxygen back into our plant that then reduces energy again, which then means we've got more biomethane available that we could actually put into other sites, put it in a tube trailer for argument's sake, and use it in a generator somewhere else or somebody else's cogen. So it's endless, the limits, the opportunities, because of this co-location with trade waste customers.
And just by an extension of that, the benefits for our customers, the North East Waters customers, John?
Look, number one, Joe, keeping prices down. So, by able to be in control of your own destiny when it comes to energy in a time when that energy transition, peak prices and prices being all over the place. This site is around about 42% of our energy consumption. So that control of that pricing means that we're able to manage better the way that we deliver our services.
Thanks, John. I have another question from Jason. Will this work help reduce odours in the nearby area? I'm going to throw that to Kevin.
Thanks, Joe. Yeah, certainly in the development of this project, providing an outcome that was better than the current state was something we spent a lot of time and effort on, and we have undertaken significant odour modelling work based on what the new project would look like, and very pleasingly, it does identify and show that the potential for odours is reduced with this upgrade facility. So. While we don't generally have a huge amount of odours discharging from the site, the likelihood of odours has reduced with this project, and primarily because we've got that high-strength trade waste covered. So any odours that might come from that can't escape to the atmosphere.
Yeah, thanks, Kevin. I've had another question. How is the project being funded? Is that for me or for you, Kev?
Well, I think it probably sits with you, Joe, but...
Yeah, look, the project is being fully funded by North East Water, and I'm really proud. And when I say North East Water, that's North East Water's customers who are contributing to this major upgrade. We have had a small grant recently to do some research. And John, do you want to just mention what that research is for?
Yeah, thanks to DECA, we've had some money to research around the opportunities of recycled water supply and what would be needed to supply recycled water to the hydrogen plant. But more importantly, what's the waste product of that recycling as well? So, all of this, when you're handling waste, there's always a fine balance around different types of waste coming into the plant. So that's a piece of work we're doing with Victoria Uni, thanks to DECA.
Yeah, thank you, John. Now, I'm just looking on here and I don't think we have any other questions. I'm just going to leave it open for another few seconds if anybody's got something. Otherwise, we might start to wrap up, and I just wanted to thank you all for joining us here today and for some of those thoughtful questions. Please stay in touch with this project via our website and help us share information about it with your colleagues and friends. And before we conclude, your feedback is very important to us, and will help us improve future community webinars. Can I ask that you take a moment to complete a short survey by using the QR code on the screen, or via a link that will be included in an email that we're going to send to you straight after this session. You can stay informed about all things North East Water via our Have Your Say website, and that website is on the screen, so please take a quick screenshot of that. And if you have any further questions or need information about anything you've learnt today, please don't hesitate to reach out to us. Thank you to everyone for attending today's webinar, to my two joint presenters, to Kevin and John, who are doing incredible work with their teams on this project I think of national significance. We hope you found the session informative, and we look forward to seeing you at our future community webinars. So have a great afternoon, everyone. Bye.